For this verbal example, I would like to show you how to perform elementary row operations, specifically using Gaussian and Gauss-Jordan elimination, using these equations as an example. First, we want to turn this into an array. But to do that, we need to write all of our linear equations in standard form. This top equation, x plus 2y equals 11, is already in standard form, so we can just keep it as it is. This bottom one, however, negative 2x equals 6 plus 5y, is not in standard form. So let's move that 5y to the other side by subtracting 5y from both sides. This now gets us negative 2x minus 5y equals 6. Now, to turn this into an array for a matrix, all we want to do is take the coefficients as well as the products. There's an invisible 1 here for the x. Don't forget that. And then we're just going to take those numbers and put them into the array. So then we get 1, 2, and 11. Then negative 2, 5, or negative 5. Careful to catch yourself. And positive 6. And then what we want to do is put these into large brackets and put a dividing line between the coefficients of variables and the answers. Now, this isn't particularly helpful. For these equations, it would seem as though there are an infinite number of possibilities that we can do. So we're going to convert these into first row echelon form and then reduced row echelon form using Gaussian and then Gauss-Jordan elimination. First, we want to make sure that there's a leading 1. There is. There's a 1 exactly where we want it. So below that 1, we want to make sure that there are zeros. To do that, we're going to perform an elementary row operation. We're going to take row 1, noted as R1, multiply that by 2. That means taking every single number and multiplying it by a factor of 2. Then we're going to take that, add it to row 2, and then we're going to replace row 2 with the answer. So 1 times 2 is 2, 2 times 2 is 4, and 11 times 2 is 22. We're going to add that to negative 2, negative 5, and 6 to get 0, negative 1, and 28. Now let's rewrite the entire array. So that'll be 1, 2, and 11. The row 1 stays exactly the same. We may have multiplied it here, but we're not going to keep what that is in this top row. Then we're going to just take the new 1, 0, negative 1, and 28, and that will replace row 2. Now we have a 0 where we want it, so we want a positive 1 right here. Negative 1 does not count. All we're going to do there is take row 2, multiply it by a factor of negative 1, and then just take that to replace row 2 this time. So I'm going to skip the algorithm right here because 0 times negative 1 is 0. Negative 1 times negative 1 is positive 1. And 28 times negative 1 is negative 28. And then we'll just keep these as we want them. And there you go. This right here, as we want it with the 1s on a slope and the 0s below them like they're skiing down a ski slope of 0s, is row echelon form. This is Gaussian elimination. And if you just want to end it there, that is perfectly fine. Technically speaking, you can revert these as they are and then solve. But I'm a little bit more, I have a preference for matrix math as opposed to doing math with linear equations. So I'm going to go a little bit further using Gauss-Jordan elimination to then convert this into reduced row echelon form. Do. So in addition to everything that row echelon form does, which is having the 1s on this ski slope, and then having the 0s under it, we also want a 0 above this one. to do that, we're going to take our 2, multiply it by a factor of -2, add that to row 1, and then replace row 1 with it. So that will look like row 2 will then become 0 times -2 is 0, 1 times -2 is -2, and -28 times -2, calculator, help me here because I just really don't want to do that, is positive 56. That will be 67, 0, and 1. Now, if we rewrite this, row 1 is being replaced with this. And then this is reduced row echelon form using Gauss-Jordan elimination. Thank you for listening.